Good afternoon, all. In the last lecture, we seen that what is the definition of coordinate vector. Okay, what is coordinate vector? If suppose E1, E2 up to so on En be a basis for the vector space V over the field K. For any small v belongs to capital V, there exists a unique scalar AI belongs to that field K. Okay, such that this V can be expressed in the form of linear combination of our basis element. Okay, that is summation I running from 1 to n ai into ei. That is equal to a1 plus a1 into e1, a2 e2 plus up to so on an en. And write down these all the coefficients in one column vector. That is a1, a2 up to so on an. This is the column vector, and this vector is nothing but coordinate vector of v to the basis related basis e. Okay, so today we will see what is the matrix representation of a transformation. Okay, we've seen that one example of this one. Okay, now the next point is the matrix of a linear transformation. Okay, now let T be a linear transformation to V over K. Okay, vector space V over K to U over K. Be a linear map. Okay, assume this is a linear map. Okay, and also let the dimension of V, that is the number of basis element in basis set, number of elements in basis set, is equal to dimension of V is m, and dimension of your codomain U is equal to n. Okay, small m and small n. And also let E1, E2 up to so on, suppose this is EM, is equal to B, and B dash, that is suppose this one is F1, F2 up to so on Fn, okay, which is equal to B dash, B basis of V, capital V and capital U respectively. Okay, what is the meaning of this sentence? This is your codomain. V over K is the vector space. U over K is also another vector space which is codomain. And this this B containing m elements is the what? Basis of our V. And the beta dash or B dash containing n elements, F1, F2 up to so on Fn. This is the basis of our codomain. Okay, respectively. Then, since, look at here, T of EI, okay, you apply the mapping on the element of what? B. B is the what? B is the subset of V here. Okay, and B dash is the subset of U. Okay, so you apply if T on EI, where I running from 1 to M. That is E1, E2 up to so on EM. This element belongs to what? U. Okay, so this element belongs to capital U, or codomain, and hence T of EI, okay, T of EI is expressed or is expressible, as a linear combination of the elements F1, F2 up to so on Fn. Why? Because T of EI belongs to U. Okay, so this element contained in U, that is U vector space, U over K. But what is the basis element of U? F1, F2, Fn. Okay, so each and every element belongs to U. We can express in the form of linear combination of F1, F2 up to so on Fn. Okay, that is linear combination of Fi. In general, we can write Fi. so that T of EI, okay, I running from 1 to n is equal to this element belongs to you can write in the form of summation. Why? Because F1, F2 is what? This beta dash or B dash is the basis of your codomain. So each and every element we can write in the form of linear combination of F1, F2 up to so on Fn. So this T of EI belongs to you. So this T of EI we can write summation j running from 1 to n aij, okay, into fj, okay. So that is P of ei is equal to, run this summation over j. If put j is equal to 1, so what we get? Ai, this is I as it is here, ai1 into f1 plus ai2 into f2 plus up to so on ain, okay, into fn. Okay, so each and every element we can write in the form of linear combination of f1, f2 up to so on fn. Okay, so instead or put, or we can write this statement can also by putting T of ei. How many elements are there? Ei m elements. So run this I from 1 to up to so on m. So we get following equations. Which one? Look at it. Following equations. T of E1. Okay, put I is equal to 1. So we get T of E1. So here AI means A11 into F1 plus A12 into F2 plus up to so on A1N into Fn. Okay, similarly, T of E2, put I is equal to 2 now. So what we get? A21 F1 plus A22 F2 plus up to so on A2N Fn. Okay, similarly, T of E3, we can write A31 into F1 plus A32 into F2 plus up to so on A3N into Fn, and up to so on this the last element T of Em. Okay, I is equal to M. So what we get? AM1 F1 plus AM2 F2 plus up to so on AMN Fn. Okay, now look at the coefficients A11, A12 up to so on A11, A1n. So the matrix of the coefficient is the matrix of the coefficient is what is the matrix of the coefficient? Look at here. Write down the all the coefficients in matrix form. First coefficient A11. Second coefficient is A12 up to so on A1n. Now for T of E2, what is the coefficient of second equation? A21, A22 up to so on A2n. Okay. Similarly, for A31, A32 up to so on A3n. Up to so on the last row is AM1, this one, AM2 up to so on AMN. Okay, so here we write all the coefficients in matrix form. Okay, so this is the what? The matrix of coefficient X. And what is the transpose of this one? It transpose is. If A is the matrix, what is the A transpose? Write down whole column in row, and each and every row becomes a column. Okay, so that is What is the first row here? A11, A12 up to so on, A1n. Okay, first row. Now row, write the first row in the first column now. A11, A, what is 1, 2 up to so on, A1m. Okay, sorry, A1n. Now this first row becomes first column. Now the second row becomes second column. Okay, A21, A22 up to so on, A to N. Similarly, up to so on here, A M1, the last column. Last row becomes last column. A M2 up to so on, A M N. Okay, any doubt? Now, how many rows are there? This is 1, 2, up to so on, n rows. N rows. How many columns are there? This is 1, 2, okay, up to so on, m. So what is the order of this matrix? N cross m. Okay, any doubt? So this is called the matrix of the linear transformation with respect to P and P dash. Okay, what is this one? The transpose of coefficient matrix. This is the coefficient matrix, and transpose of this matrix is this one. And this matrix is nothing but matrix of the linear transformation T with respect to beta, sorry, B, that is the basis of our vector space V over K. And this beta, B is what? Look at here. This B is vector space. Sorry, this is B is the basis for V, and beta dash is the basis for U. Hence, we get the matrix of linear transformation T with respect to B and is transpose of the coefficient matrix, and which has an order n cross n. Okay, so this is the matrix of a linear transformation. आता इथे पहा, ह्याची डायमेन्शन किती होती? What is the dimension of V over K is m. What is the dimension of U over K is n. Okay, so this is m and this is n. तुमच्या कोडोमेनचा जो जितका काही हे असेल डायमेन्शन, ओके, whatever be the dimension of your codomain, vector space codomain, this is the codomain. So what is the dimension of this one is n. So at the end we get n rows. Okay, so number of rows is equal to what? Dimension of codomain. Okay, and number of columns, that is m, is equal to dimension of your domain space, that is V over K. Okay, and this matrix is nothing but matrix of linear transformation with respect to B and beta. ओके, इथे बी आणि बीटा काय घेतलंय? बी आणि बी डॅश काय घेतलंय? कारण की तुम्हाला बेसिस दिलेला आहे इथे E1, E2 and up to so on EM. This is the basis B. काही वेळेस बेसिस वेगळेही असू शकतात. Okay, so here F1, F2 up to so on Fn is the B dash, which is basis of our codomain. Okay, so number of rows is equal to dimension of our codomain space, and number of column is equal to number of domain space. Okay, now the next point is matrix representation of a linear operator, or matrix representation of matrix representation of linear operator. First, we are going to see what is the linear operator. We know that linear transformation, we know. But what is the linear operator? A linear transformation, Okay, over the vector space V over K to V over K. That is, in our linear operator, your domain and codomain must be same. Okay, so this is the definition of linear operator. What is linear operator? The transformation, the linear transformation with same domain and same codomain. ओके. जर इथे यू असेल तर हा लिनियर ट्रान्सफॉर्मेशन, जर इथे व्ही असेल तर तो लिनियर ऑपरेटर. डोमेन आणि कोडोमेन तुमचं सेम असायला हवं. सो दिस इज द डेफिनेशन ऑफ लिनियर operator. Now we will see what is the metric representation of linear operator. Okay, let capital T be a linear operator, that is linear transformation. Linear transformation with same domain and codomain. Operator. Okay, let T be a linear operator on vector space V over the field K. Okay, and let, this is the basis, E1, E2 up to so on En. Okay, be a basis of V over K. ओके, आता इथं एकच बेसिस लागेल कारण की तुला डोमेन आणि कोडोमेन काय सेम आहे, V over K. Okay, so they here no need to give the basis of our codomain. Okay, so here let E1, E2 up to so on En be a basis of V over K. Since T is the linear operator from V over K to V over K. Okay, now since T of EI, if we apply T on each and every element of the basis element of V over K, now this T of EI, ha EI तुमचा याचाच. So if we apply TI, then it becomes the element of, again, our codomain, that is V over K. Okay. So hence, here T of EI be the element of V over K. Okay, so each T of EI is a, again, linear combination. Linear combination of the elements of the basis EI. Okay, so this Ti belongs to what? Our codomain. But what is the basis of codomain? Again, E1, E2 up to so on En. So hence this T of EI we can write in the linear combination of E1, E2 up to so on En. Okay, so write this T of EI is equal to summation, again, J running from 1 to now N. Okay. Yes. Summation J running from 1 to N A I J E J. Okay, that is how we can write this one. T of EI, T of EI. Now run this summation. AI1 E1 plus AI2 E2 plus up to so on AI N En. Okay, for all I is equal to 1, 2 up to so on N. Okay, now run this I from 1 to N now. Now what is T of E1? What is T of E1? Put I is equal to 1. A11 E1 plus A12 E2 plus up to so on A1N En. What is T of E2? A2 2 1, put I is equal to 2 now, E1 plus A 2 2 E2 plus up to so on A 2n En up to so on T of En now, the last element. Put I is equal to 1, N A N1 E1 plus A N2 E2 plus up to so on A N N En. Okay, so what is the matrix of the coefficient? This implies the matrix of the coefficient. Write down all the coefficients in one matrix. Each. What is first row? A11, A12 up to so on A1n. Okay. A11, A12, A13 up to so on A1n. Second row, A21, A22, A23 up to so on A2n. And last element, AN1, AN2, AN3 up to so on ANN. This is the matrix of coefficient. And if we have to find the matrix of transformation or matrix of operator, this implies the matrix of linear operator is what transpose is equal to, write down first, write down equal to transpose of the coefficient matrix, Okay, now write down the coefficient matrix. That is, now how we can denote this one? The matrix T. Okay, matrix of T with respect to what? Basis is B, na? That is E. Okay, we can write B. B is the basis of our domain and codomain. Here the domain and codomain becomes same. So this is equal to, now write down what is the first column. Here the first row becomes first column, A11, A12, A13 up to so on A1n becomes first column, A11, A12, okay, A13 up to so on A1n. Second column, second row becomes second column, A21, A22, A23 up to so on A2n. Similarly, A31, A32, A33 up to so on A3n, and up to so on the last one is AN1, AN2, AN3 up to so on ANN. Okay, how many rows are there? 1, 2, 3 up to so on n. So n rows are there. How many columns are there? Also n columns are there. So n rows and n columns are there. Hence, the matrix of a linear operator must be a square matrix. Okay, the matrix of a linear operator, any linear operator, must be a square matrix. So this is the transpose of a coefficient matrix is equal to matrix of a linear operator. Any doubt up to here? एखादं एक्झाम्पल घेतलं की व्यवस्थित येईल समजा. ओके, एनी डाऊट अप टू हियर? रिप्लाय द्या काहीतरी. हॅलो.
No, sir.
Okay. So we will move towards the example. Okay. First, let capital T from R2 to R2. Okay, 2 dimension. and here the domain and codomain must be same. So here the T is what? Linear operator. Okay, be a linear operator. Sorry, linear operator. The linear operator is nothing but what? It is a transformation from same domain to same codomain. Okay, and given by such that T of xy, okay, ordered pair. R2 is there, that's why here ordered pair. T of xy is equal to, what is that transformation? 2x first coordinate and second coordinate is y upon 2. Okay, so multiply the first coordinate with 2 and divide the second coordinate by 2. Okay, so this is the equation. So this is the question. So find here matrix. Find matrix associated with the transformation T, or that is map T, with respect to with respect to ordered basis. Ordered basis given to us, first basis, standard order basis 1 0 and 0 1. This is the basis of our R2 domain and codomain, and you have to find the matrix of transformation. Okay, solution given. What is given to us? T is the mapping from R2 to R2. Okay, such that T of xy is equal to 2x and y upon 2. Okay, for all xy belongs to R2. Okay, now what is E1? E1 is given to us 1 0, basis element. What is E2? E2 is again 0 1. Okay, why this one is basis? Because this is the linear independent set, and this set must spans our whole vector space R2. Okay, so this is E1 and this is E2. Now this is xy belongs to R2, be any element. So this implies we can write this x into y is equal to, how we can write this element in the linear combination of this one? This is x into E1 plus y into E2. Okay, y into E2. Is it correct? That is x into 1 0 plus y into 0 1. Okay, this is the x y. Now we have what we have, the linear transformation. Apply t on both sides. So t of xy is equal to what? T of x into 1 0 plus y into 0 1. Okay, but t is the linear transformation. So this is x into what? T of 1 0 plus y into t of 0 1. Okay, but we don't know what is the value of t of 0 1 and t of 1 0. But we have t of xy is equal to what? 2x and y upon 2. So put here instead of x 1, instead of y 0. So what we get? 2 and 0. Okay, and what is the value of t of 0 1? Is equal to 0 1 by 2. Okay, so but we have this one. Now write down, this is the equation 1. Okay, any doubt? Any doubt up to here? Okay, so hence t of xy is equal to what? X into, what is t of 0 1? T of 1 0 is 2 0. plus y into hmm, t of 0 1 is 0 1 by 2. Okay, so this implies what we have 2x into 0 tx and 0 plus 0 and y upon 2, which is equal to what? 2x plus 0 is 2x, y plus y by 2 plus 0 is y by 2. Hence, hmm, this is right down in bracket. Hence, we have t of xy is equal to t of 2x comma y upon 2. म्हणजेच now we have to find the matrix of linear transformation. Okay, so find the t of 1 0, which is equal to what we have instead of 2 0. Okay, so that is we can write in this. This is what? This is the element of our codomain, that is R2. Okay, so which is equal to 2 into 1 0 plus 0 into 0 1. Okay, now t of 0 1, which is equal to what is t of 0 1 from this one? 0 1 by 2. So write down this vector in the linear combination of bases. So this is 0 into 1 0 plus 1 by 2 into 0 1. Therefore, coefficient matrix. What is the coefficient matrix? Is 2 0. Okay, and 0 1 by 2. Okay, hence the matrix of linear transformation that is equal to T with basis B. Okay, standard order basis, which is equal to what? Transpose of this one. What is the transpose of this one? First row becomes first column here, 2 0, and second row becomes second column, that is 0 1 by 2. Hence this is the matrix of linear transformation. Any doubt? काही doubt असतील तर विचारू शकता. Okay, so here we find the matrix of the linear operator t of xy is equal to 2x comma y upon 2. Okay, any doubt up to here? आहे का काही डाउट्स असतील तर विचारा.
No, sir.
No, sir.
Okay, so we will move towards next point, next example, second one. Let V2 over F, that is R2. Okay, T with the mapping from V2 over F to V2 over F. Okay, that is, or we can write this T from R2 to R2. Be a linear map. Be a linear map. Okay, defined by T of AB is equal to first coordinate as it is, second coordinates transform to 0. Okay, so compute the matrix T, the matrix capital T relative to standard ordered basis. Standard ordered basis. Okay, we have to compute the matrix T relative to the standard ordered basis. Solution. Okay, so basis, standard ordered basis for the V2. Okay, what is V2? V2 is nothing but R2. So this is the basis set 1 0 and 0 1. This is the standard ordered basis for R2. Okay, now write down all the given thing first. T is the mapping from V2 over F from V2 over F to V2 over F. Okay, it's a linear map.
ती नहीं थी.
Any problem? काय अडचण आहे का कोणाला? The linear map defined by T of AB is equal to A0. First coordinate as it is, second coordinate transformed to 0. Okay, give it as an equation number 1. Let this B is equal to E1 and E2, which is equal to standard ordered basis. Okay, where E1 is equal to 1 0 and E2 is equal to 0 1. Okay, now find the T image of E1, that is equal to T of 1 0. First coordinate is as is, second coordinate transformed to 0 from equation 1. Okay, first coordinate A ha asat hai, ite h value ite 1, 1 is as it is, and second coordinate is 0, so 0 is as it is. Now T of E2, what is T of E2? T of 0 1. First coordinate as it is, 0 is as it is, and second coordinate transformed to 0. Okay, now this is the element of what? R2. This is the element against R2. So this element we can write in the form of linear combination of basis element of R2. Okay, so this implies 1 0. We can write 1 into 1 0 plus 0 into 0 1. Okay, these are the two elements of basis elements of R2. 1 0 plus 0 1. Okay, now write this element, which one? 0 0, in the linear combination of these two. So what is the value of this one here? This coefficient is 0, again this coefficient is against 0. Okay, so this implies coefficient matrix. What is the coefficient matrix? Is equal to 1 and this one is 0 0 0. Okay, now the matrix of T with respect to basis beta. Okay, so we get transpose of this one. What is the transpose of this one? First row becomes first column, 1 0, and second one is 0 0, second column. So hence T of beta, okay, matrix of T with respect to beta is what? Matrix of a linear transformation with respect to beta. Okay, now we will move towards the last example of our syllabus. Okay, last example, last one. Third one, find the matrix representation. Matrix representation of a linear map. Of a linear map. T from R3 to R3. Okay, order triplet now. Given by, which is defined by T of X, Y, Z is equal to, first coordinate is Z, second coordinate is Y plus Z, third coordinate is X plus Y plus Z. Okay, म्हणजे हा Z इथे येईल x plus y plus z is 3, and x plus y plus z is third coordinate. Okay, relative to the basis, relative to the basis, and basis set is given to us 1 0 1, minus 1 2 1, and third is 2 1 1. Okay, now solution. Write down first all given things. T be the mapping from R3 to R3. Okay, is what is a linear map. Is a linear map such that T of x, y, comma z is equal to what is given to us? Z, y plus z, x plus y plus z. Okay, and what is B given to us? B is equal to E1, E2, and E3 such that which is equal to 1 0 1, minus 1 2 1, and third one is 2 1 1. Okay, 2 1 1, where E1 is equal to what? 1 0 1. E2 is minus 2 minus 1 2 1, and E3 is given by 2 1 1. Okay, this set is linearly independent and this set spans your whole R3 space. That's why this B is basis. Okay, now write any element x, y, and z. Okay, this is the element of R3. So we can write this element in the linear combination of E1, E2, E3. Suppose x, y, z is A into E1 plus B into E2 plus C into A3. Linear combination of E1, E2, E3. Okay, so this implies x, y, z is equal to A is as it is. Okay, what is E1? 1, 0, 1. Now B is, what is E2? Minus 1, 2, 1. Okay, plus C into, what is E3? 2, 1, 1. So this implies we get first coordinate is A minus B plus 2C plus 2C. Okay, now second coordinate is A into 0, 0. B into 2 is 2B, okay, plus C. And third coordinate is A plus B plus C. Okay, so this is what x, y, and z. So we can write any element x, y, z belongs to R3 in this format. Okay, now comparing the coordinates, what we get, x is equal to A minus B plus 2C. Y is equal to 2B plus C. Okay, and Z is equal to A plus B plus C. Okay, any doubt? So now here we have three equations and three unknowns A, B, C. Now you have to find the value of what? A, B, and C in terms of x, y, z. Okay, if you solve this equation, these three equation for A, B, C. Okay, solving above equation in solving above equation to find A, B, C in terms of x, y, and z. येईल सॉल्व करता का सॉल्व करू दे. So solve it. If we solve these three equations, then we get A is equal to, in terms of x, 1 by 4 minus x minus 3y plus 5z. This is the first coefficient A. And value of B is 1 by 4 minus x plus y plus z. Okay, that is second coefficient, this one. And c is equal to 1 by 4 2x plus 2y minus 2z. ओके, या तीन इक्वेशन मधून मला ए बी सी ची व्हॅल्यू फाइंड आउट करायची आहे. त्याच्यातनं काय मायनस करताय काय ऍड करताय पाहते. ओके, so we get the value of a b c. So hence now putting this a b c in this equation, give it as an equation number 1. Okay, so x y and z is equal to value of a is 1 by 4 minus x minus 3y plus 5z into what? E1. Okay, plus b into, that is 1 by 4 into minus x plus y plus z into E2 plus c into, that is 1 by 4 into 2x plus 2y minus 2z into E3. Okay, now find t of E1 now. T of E1, which is equal to what? T of E1 is what? E1 is 1, 0, 1. Okay, now put x is equal to 1, y is equal to 0, and z is equal to 1. Okay, so we get, what is t of x, y, z? Put here 1, 0, 1. So here we get 1 y plus z, that is 0 plus 1 is 1, and x plus y plus z, x plus y plus z is 1 plus 1 is 2. Okay, so image of 1, 0, 1 is equal to what? 1, 1, 2. Okay, similarly t of E2 define, that is t of minus 1, 2, 1, which is equal to, we get then 1, 3, 2. Okay, by the above mapping. Similarly t of E3, which is equal to t of 2, 1, 1. Okay, this is the third coordinate, third E3, third basis element. We get this one is 1, 2, 4. Okay, now hence now this is 1, 1, 2, 1, 3, 2, 1, minus 2, 1, 2, 4. Okay, hence we get t of E1 is equal to 1, 1, 2. And this vector we can write, put here now 1, 1, 2. So instead of x, put 1. Instead of y, put 1. Instead of z, put here 2. So and after solving, we get t of E1, that is 1, 1, 1, is the linear combination of, this is 3 by 2 into this E1 is as it is. Okay, look at here. Put here 1, y is 1, z is 2. So what we get? Minus 1, minus 3, minus 4. Minus 4 plus 2 is minus 2. Okay. Sorry, minus 3 plus 5. This is 10. Okay. Minus 1, minus 1, minus 1 into minus 3. Minus 1, minus 3 is minus 4. Minus 4 plus 10. That is minus 4 plus 10 is 6. And 6 by 4 is nothing but 3 by 2. Okay. Similarly for here, 1, 1, 2. We get this one is 1 by 2 and E2 is as it is. Similarly for here, t of, put here 1, 1, 2. So here we get 0 into E3. Okay, so here t of E1 we can write in the form of linear combination of E1, E2, E3. Similarly, t of E2, which is equal to what? 1, 3, 2. Now put x, y, z is equal to 1, 2, 3. So here we get 0 into E1 plus 1 into E2 plus 1 into E3. And t of E3, which is equal to 1 to 4, which is equal to 13 by 4 E1 plus 5 by 4 E2 plus minus 1 by 2 E3. Okay, now what is the coefficient matrix then? Coefficient matrix, which is equal to 3 by 2, 1 by 2 and 0. 0, 1, 1. 13 by 4, 5 by 4, minus 1 by 2. Okay, so now what is the matrix of T with respect to the basis beta is equal to first row becomes first column. This is 3 by 2, 1 by 2 and 0. 0, 1, 1. 13 by 4, 5 by 4, minus 1 by 4. So this is the matrix of representation. Okay, such that T of x, y, z is equal to z, y plus z, x plus y plus z. Okay, with ordered basis given to us. Okay, so this is the end of our syllabus. Okay, any doubt up to here? इथे तुमचा सिलेबस संपलेला आहे.